Hello, and welcome to the secret YouTube channel documenting the game dev for my new game, Kernel Panik. In this video, I'm going to talk over the two different scripts I have made for this game, one which shows the rendered content onto the screen, and another which is a screen editor. Let's talk about the first script, which you can see on the screen now. We are using Pygame to actually show the rendered content onto the screen, but Pygame is stupid in the fact that it prints a message when loading the library, which, other than being bad practice, makes a console window open when the program is compiled to a .executable. In order to stop Pygame showing this, we use this bit of code to hide the support prompt, which just sets an environment variable to 1. So this is the bit of code that sets it to 1, and as you can see, it hides Pygame support prompt. Just below this script is the first function, which is callable via other programs for the game, like the render or main game loop. This function converts the colors we send to full color. This is because the rendering program uses 8-bit color, which uses 3 bits for red, 3 bits for green, and 2 bits for blue. This is okay, as the human eye is not adapted to see the colour blue as well as red or green, so blue only needs 3 values, 0, 1 and 2. Here is a picture containing all the colours our game will have. It's not very many. We need to convert to full colours. Pygame uses 24-bit colour, which is a lot more than 8. So we set each 8-bit colour to the 24-bit counterpart, meaning our game only has 256 colours, instead of the measly 16.7 million displayable by 24. To do this, we use bitwise shifts, which are these arrows, like double arrow symbols here, to expand the colour components to make them compatible with full RGB. For example, the 332 colour 132 would be converted to something like 32, 224 and 192 in 24-bit colour. Now we move on to the code which actually renders the colours onto the screen here. This function has a few parameters or inputs, which are screen. This is where the pixels will be displayed, and you make it in the main program, so it can be different sizes. Grid. A 2D array where each element is a 332 color value stored as a tuple R, G, B. And cell size, which is the size in pixels of each pixel. This program calls it cells, should be in order to make the viewing possible, otherwise it would be tiny. The screen data is passed in an array in order to make certain screen effects easy to edit, also making it easier to edit by the programmer. This slice of code loops through each row, and so this slice is the bit that, where is it? This line goes each row in the grid, and this line goes for each cell in the row in the grid. It's quite confusing. This uses pygame.draw.rect for each pixel whose position is multiplied according to its location. If this script does not receive an expected 3-color tuple, then an error message is printed out for debugging, which is quite helpful. Now, in order to show text, we need a separate renderer layer. This is called the text grid in my program because it's a grid of text. This is similar to the color grid, but other than the normal tuple, it expects a text character in the array as well. Each element in the text array looks like this. So there is a character, and then there is a color tuple, so RGB. Now, we will talk about the program I have used, which enables us to draw the actual pixels that are rendered by this program. So that's this program here. Scroll up. This is a bit of a longer program. As always, we have to initiate Pygame. Blah de blah de blah. We've talked about this before. But this does more than just rendering the screen in the script. Now we set up the screen array to its 80 by 80 size. Next we will set up the color palette here. Which is our 8-bit format. And once again, we convert this 8-bit format color to its normal colors by multiplying red by 36 and green by 36 and blue by 85. Now, in order to select different colors, we need to see the different colors. Which this function here does. So it makes squares of every single color, so the 256 colors, and if one of those colors is clicked, it outlines that color with a white outline. Now, if you want to save the pictures we've drawn, this is what we need to do. This is the function we use. So it literally pastes the array of colors into a file, basically, and it prints out a message just to show you it worked. Now, if you want to edit a file, which is useful, this is a function which does it. So it takes the same file that it saved to, and it loads it, and then it loads it into the array, which then gets shown on the screen to run the programmer, just so you can edit the colors and stuff. Now we move on to the main program loop. Where is it? This program here, this this function here draws the grid or the canvas and the cursor. So if the cursor is shown over one of the pixels, it outlines that pixels or cell with a white outline, which is quite helpful so you know where you're drawing. So that's what the draw cursor position does. It also draws a selector color indicator here as well. Now we move on to the input handling. So here we have the key S, which is down here, runs the dump colors to file function, which saves it. The key L loads the picture from the file, and then the key A toggles arrow mode, where you just draw. You can move the cursor with the arrow key so you can be more precise with your pictures. And also with that, when you're using that mode, you can press the space bar to place the colour. Otherwise, when you're using the cursor, you can use mouse button down. So yeah, these are the programs I've made. Let's give a demo of the drawing program first. This is one I've got open. So when I run it, it opens this here. So you can see you've got the grid around here. If I press A, you can now move it like that. But if I wanted to say select, I don't know, red, or this is like purpley red, you can, and then you can go, you can draw a lovely thing here. But when I press S, it says down here, color array dumped to colors dump.txt. So if I close this program, and if I didn't, this is the wrong one. So I've saved it. If I run this program again, you can't see anything, but if I press L, it loads it, and I can edit it like this, etc., etc. But it also means I can load other pictures. So if I get, what one's a good one? Where was it? So this is what the actual color picture looks like. It is. And if I go and paste this into, I think it's colors dump.txt, whose location is here. I go and paste it. Doesn't look like I've done anything, but trust me, when I run this program, there we go. And press L, it says Kernel Panik, which is the picture I got loaded into the program. So yeah, that's about it for this video. Thank you for watching. Like and subscribe if you liked the video, and comment and subscribe if you didn't. Come back in a few weeks to talk about the next part of my game, Kernel Panik. Goodbye.